In the last video, we talked about all the different types or all the different number of solutions that there could be to a linear equation. And now we're going to try and solve a few problems on infinite solutions to linear equations from the SAT. And so this first one says, in the given equation, b is a constant. So we have this equation and b, they say, is a constant. If the equation has infinitely many solutions, what is the value of b? So let's just take a moment to remind ourselves of when there are infinite solutions. So if there's a linear equation and you do all your operations and you try to solve it, and you end up with something like 2 equals to 2 or 0 equals to 0, and these are both actually the same thing, because like if you subtract a 2 from both sides here, you get to a 0 equals to a 0. And when you have something like this, you have infinite solutions. And this will only happen when the x terms on both sides of the equation cancel out, because when the x terms will cancel out, that is when you would have no x terms and only two constants equal, and those constants also will have to be equal to each other. And we're going to use this fact to solve these problems, because essentially all we need to do here is just compare the coefficients. I'm going to write that down. Compare coefficients and the constants as well, because in the case of infinite solutions, both the constant terms and the variable terms have to be equal on both sides. So to find b, actually let me write this in a more, let me simplify this a bit. So on the left hand side, I can write this, I can divide both of them by this 2, so it would become 2x plus b over 2 equals to a 2x plus an 8. And as you can see, the x terms do cancel out when I subtract a 2x from both sides, and the constant terms also have to be equal. So this b over 2 has to be equal to my 8, and so because b over 2 is equals to 8, b has to be equal to 16, and so the correct option is D. And you can do all of this in your head. You didn't even need to write anything down. You just have to look at the constant terms on both the left hand side and the right hand side and equal them to each other in your head. So when I see this question, I would go there and I would see this 8 on the left hand side and the b over 2 on this side, and I would know both of these are equal, and so b has to be equal to 16. And so let me scroll down to the next question, and I encourage you to pause the video and try this one on your own, and try to do this as fast as you can in your head. So once again, in the equation above, a is a constant. For what value of a does the equation have infinitely many solutions? They could also have said, for which value of a is the equation true for all values of x? That would also have meant the same thing. And so once again, you just have to compare the coefficients on both sides. So for in this case, there's an ax here and a 2x here, but this is actually going to be a negative 8x. Let me actually expand this out for you. Ax minus a 12, when I multiply this minus 4 with the 3, and then the negative 4 times a plus 2x is going to be a negative 8x, and that is equals to a negative 12. And so now we just need to compare the coefficients. The constant terms are indeed equal, as we can see. The negative 12 is equal to the negative 12, and in this case the x term has a coefficient of 0, and so whatever the x terms are on the left hand side, they have to be equal to a 0. They have to add up to a 0. So how will this become a 0? The a has to be an 8, because an a minus 8, if I combine them together, I can write this, the coefficient of x on the left hand side is equal to an a minus 8, and so a has to be an 8 in order for the coefficient of x to be 0. And once again, you could have done this in your head. You could have seen that x here was a negative 8, there was a negative 8x, and so a had to be an 8x in a a had to be an 8 in order for this to become 0, in order for the x terms to cancel out. And I just want to give a little note here that in this case, in both these questions, you had to calculate only one constant. There could have been two constants as well that you would have to calculate, that they could have asked you to calculate. They could have been, this one was for the x term, there could also have been one for the constant term. There could have been a b here instead, and you would have to calculate that as well. Sometimes they may even ask you for something more than that. They could ask you for an AB. In that case, you would just have to multiply them together in the end. And so that's about it for this video. I hope to see you in the next one.